Assalamualaikum and good day to the judge. My name is Suen and together with my team, we are presenting our project titled Effluent-Based Cultivation of Chlorella vulgaris for Simultaneous Ammonium, Nitrate and Phosphorus Reduction in Ethanol Production Wastewater. Industrial wastewater from ethanol production contains high levels of ammonium, nitrate, and phosphorus, which can cause serious environmental pollution if discharged untreated. In this study, we introduced a dual-function fecal remediation approach using Chlorella vulgaris. Unlike conventional systems that depend on synthetic growth media, our method uses the wastewater itself as both the cultivation medium and treatment solution. This means the nutrients present in the wastewater are directly utilized to support microalgae growth while simultaneously reducing pollutant levels. The main focus of this study is to optimize key operating parameters to maximize nutrient removal efficiency in a sustainable and resource-efficient way. Chlorella vulgaris is a freshwater green microalga known for its high growth rate and strong adaptability. It contains functional groups such as hydroxyl, carboxyl, and amino groups that enhance nutrient uptake. It removes nitrogen and phosphorus through biological assimilation and improves water quality by producing oxygen through photosynthesis. Additionally, it is sustainable and cost-effective, with potential applications in biofuel and animal feed production. The problem statements in this study are: first, high nutrient content in wastewater leads to environmental issues such as eutrophication. Second, conventional treatment methods are costly and require chemicals. Third, microalgae cultivation typically depends on expensive synthetic media. Lastly, there is limited use of ethanol wastewater as a direct growth medium. Therefore, a more sustainable and cost-effective solution is needed. The objectives of this study are: first, to evaluate the effects of wastewater concentration, lighting exposure, and microalgae dosage on nutrient removal using Chlorella vulgaris. Second, to assess the nutrient removal performance of Chlorella vulgaris under optimized conditions. The experiment was conducted using a closed batch system with a 2000 ml beaker containing 1000 ml of ethanol wastewater. Microalgae were directly inoculated into the wastewater. 4 LED lights were used to provide illumination, and the experiment was conducted for 10 days at room temperature. The parameters studied include wastewater concentration, lighting exposure, and microalgae dosage, while pH was maintained at 7. Nutrient concentrations were analyzed using a DR3900 spectrophotometer. In this study, several parameters were optimized. Wastewater concentration ranged from 10% to 100%, lighting exposure from 8 to 24 hours, and microalgae dosage from 100 to 500 ml. Each parameter was varied individually, while keeping others constant to determine the optimal condition for maximum nutrient removal. The percentage removal of ammonium, nitrate, and phosphorus increased from 10% to 50% wastewater concentration and decreased from 75% to 100%. The maximum removal was observed at 50% concentration, with ammonium at 61.41%, nitrate at 67.5%, and phosphorus at 54.5%. This is because lower concentrations limited by insufficient nutrients, while higher concentrations show reduced efficiency due to inhibitory effects. For the effect of lighting exposure, the removal efficiency increased from 8 to 12 hours of lighting and decreased at 16 to 24 hours. 12-hour light and 12-hour dark cycle was identified as the optimal condition, with percentage removal for ammonium at 56.69%, nitrate at 84.38%, and phosphorus at 71.88%. This is because sufficient light enhances photosynthesis, short exposure limited photosynthesis, while excessive exposure reduced efficiency due to stress or photoinhibition. For the effect of dosage of microalgae, the removal efficiency increased from 100 ml to 300 ml dosage and decreased at higher dosage. The maximum removal was at 300 ml, with ammonium at 65.52%, nitrate at 80%, and phosphorus at 55.33%. Higher dosages may cause increased competition among algae cells for nutrient, light, and space. Lower dosage have insufficient quantity of microalgae to efficiently absorb the available nutrients. Under optimized conditions, nutrient removal shows fluctuating trends. For ammonium, removal decreased initially and became negative after day 3. This indicates possible release of ammonium due to biological processes such as deamination or conversion to nitrate. For nitrate, removal trend fluctuated, reaching the lowest point at day 7 before slightly recovering by day 10. This is due to nitrogen transformation processes such as nitrification. For phosphate, removal increased rapidly to about 45% at day 3, then fluctuated. This is due to rapid initial uptake followed by possible release under stress or nutrient limitation. These fluctuations may highlight the dynamic biological behavior of microalgae in the wastewater treatment. In conclusion, Chlorella vulgaris is effective for fecal remediation of industrial wastewater. The optimal conditions were 50% wastewater concentration, 12 hours lighting exposure, and 300 ml microalgae dosage. Nutrient removal is influenced by both operational parameters and biological processes. Due to these reasons, phosphorus uptake still effective but inconsistent in ammonium and nitrate removal. The novelty of this study lies in using wastewater as both a growth medium and treatment system. It enables simultaneous removal of multiple nutrients without the need for synthetic media. This approach is sustainable, cost-effective, and resource-efficient. This study contributes to sustainable wastewater treatment by reducing operational costs and eliminating the need for synthetic media. It also improves water quality while producing biomass with potential economic value. Overall, it provides a practical and environmentally friendly solution for industrial wastewater management. Thank you for your attention. We hope this study contributes to more sustainable and efficient wastewater treatment solutions. Thank you.